determine the forces acting in all the members of the truss shown in the figure. So we have the method of joints and method of sections that we can use to solve the forces acting in all the members of this truss. But let us use the third method, and that is by graphical method. And we'll be using AutoCAD for this one. So I have sketched this one in AutoCAD. Here, let us first solve the reactions at A and C. For C, since it's a roller, the reaction here is just a vertical force acting on point C. At A, because this is a hinge, the reaction here is at a certain angle, and we do not know the magnitude of that angle. So let's assume it's going in this direction. Okay? So this is just an assumed direction of the reaction at A. This we are going to solve using the graphical method with the help of AutoCAD. First thing we need to do is by the way, this is called the space diagram. Then on the right, I am going to draw the force diagram. First, let's put a level in between each of the force. Let's say we'll just use a number. So this number 1. In between the reactions at C and A, you have number 1 here. And between the reaction at A and this 3 kilonewton force, let's put number 2 here. And between 3 and this vertical reaction, let's put 3. So here's our level 1, 2, 3. Then on the right side, I'll draw the force polygon. This will be called the force polygon. So first, I'm going to sketch a line that will represent this 3 kilonewton load. So that's 2, 3. So we'll have a line from here to here that is 3 kilonewtons. Let's say it's 3,000 units here. This will be your point 2, and this is point 3. Okay? So 2, 3, clockwise, 2, 3, 2, 3. This is, what is this? This will be 3 kilonewtons. Next, we are going to draw a point, an arbitrary point anywhere over here. Let's say here. Okay. So you can put this anywhere, an arbitrary point. This is also known as the vector point. Let's put it here. Then next, I'm going to draw the line of action of all these forces here, starting with the 3 kilonewton force. That will just be horizontal. This one is vertical. This one here, we don't know the direction. It can be in this direction, here, or here, or here. We don't know, no? So let's just say S1. This is just an assumed direction. Next, we'll connect this vector point to each point 2 and 3. Let's use another color. Let's connect this point 2, and let's use another color for this 2, 3. So this is line 2, or the line that will connect the line of actions of this force and this force. That's 2. Now, because this is not the exact direction of the force, it could be again in this direction, or in this direction, or in that direction. But one thing is clear, that all of these lines will intersect at point A. So what we're going to do is to copy this magenta line and put it here, A. And this magenta line is going to intersect with the line of action of 3. Let's extend this one a little bit. So now it intersects this line, and then we'll copy this and put it here. So this is now line 3. So that's the line between the line of action of the 3 kilonewton force and the vertical reaction RC. It's going to intersect this line and this line. So you will extend this so that it will intersect this line. And then the line that will intersect this line of action and this line of action will be our point 1. So let's use another color. It should close this one and intersect this line of action. And then we'll copy this and put it here. Okay? So we are now going to locate point 1. We have 1, 2. We don't know where point 1 is. But we know that here at 3, there's a vertical force going up. So from 3, there should be a line that goes up over here and should intersect this line 1 here. So this will be our point 1. Okay? So the line that is going to close this force polygon is the reaction at A. So therefore, the direction of the reaction is here. So we are going to rotate this. So that's the direction of the reaction, or the line of action. But the direction of the force will be, that's 1, 2, or clockwise direction, that's 1, 2. 1, 2. Going here, 1, 2 is going that way, 1, 2. So to the left and down. That means this is, the reaction should be in this direction. From here, going down here. So that's our reaction RA. Okay, so how much is our reaction? Our reaction RC is 3, 1. 3, 1. So that's 3, 1 going up like this. And how much is that? Let's just measure this one. That's 1.5 kilonewtons. So this is 1.5 kilonewtons. And how much is this? That is 3.35 kilonewtons. But we want the components of these reactions. So you want the horizontal component, which should be directed this way, and the vertical component is going down that way. So how much is this? This is the component of this one, which is this horizontal line that is also 3 kilonewtons. So that means this is 3 kilonewtons. How about this? That is this one. So that's 1.5. Okay. So we can now erase this, and these are our reactions. 1.5 at C going up, and then we have the horizontal component here, it's 3 kilonewtons to the left and 1.5 kilonewtons downward. So this is now in equilibrium. So let us solve the forces in each of the members. Let's copy this truss first and the reactions. So now we are going to solve the forces in each of the member. Again, we'll be using AutoCAD to do that. So first, what we're going to do is to again put a label in between each of the forces. Let's just use small letters here. Let's small letter A. That's between this 1.5 and this 1.5. Then next, between this and this force, let's call that point B. Between this force and this force, let's call that point C. And between this 3 kilonewton force and this reaction, let's call that point D. Okay? So we now have the labels in between each of the forces A, B, C, and D. Then we are going to add labels inside the truss. This time, let's use numbers. 1. So in each triangle, we'll put a label. That's 1. And this one, let's call that 2. So this is our space diagram. And we will draw the force polygon here on the right side. So let's start drawing the force that will represent the 1.5 kilonewtons. That's force AB. AB. So a line going down. 1.5, let's say 1,500 units. This should be 1.5. And then next to that is this 3 kilonewton force to the left that will continue from A, B. Let's call this our point A, and this will be our point B. And then starting at B to C, there is this horizontal force to the left that is 3 kilonewtons. Let's say 3,000 units. So this will be our point C. Then from C to D, there's this 3 kilonewton to the right, so it goes back here. So this is both point B and point D. And then from D to A, it goes back up by 1.5, and that's our point A. So this is our force polygon. So now we will start solving the forces in this member. Let's start with the force in member AB. So if you consider point A going clockwise, this will be called C1. Okay? C1. So we are going to draw a line here that is parallel to this, or the same direction as this one. And it is going to pass through points C and 1. But in the force polygon, we only have point C. We don't know where 1 is. So if we are going to draw a line that is parallel to this, or let's just copy this line should pass through point C. We don't know where point 1 is yet. It may be here or here, we don't know. But if we go to the next member AD, considering point A, clockwise would be 1A. So we're going to draw a line parallel to this that will pass through points A and 1, or 1 and A. Again, we don't have point 1, but we have point A. So we'll copy this. It is going to pass through point A. So this line is going to pass through point 1. This is also going to pass through point 1, meaning the intersection of these two lines should be point 1. So that's point 1. So remove this excess lines. So this is C1, this one is 1A. Next is this line, 1, 2. So considering point D, we have line 1, 2 that is vertical. We have point 1, but we don't have point 2. But we know that this line is going to pass through point 1. So how are we going to locate point 2? Okay, let's consider point B. We have, remember, BC is represented by the line D2. So a line that will pass through point D and point 2 and is parallel to this. So let's copy this line, and we know that it will pass through point D and 2, but we don't know 2. So this will pass through point 2. This will also pass through point 2. So these lines are going to intersect at point 2 over here. So that's our point 2. So we now have point 1, point 2, and all the letters A, B, C, D, but we don't have, remember, A2 yet, A2. So A2, it's going to pass to point A and point 2. So let's copy this line, put it at A, and it is going to intersect with this line. So that's A2. So this is now our completed force polygon. We can now determine the magnitude of the force in, for example, C1 is this line here. So how much is this? That's 0.78 kilonewtons. How about the sense? Is it tensile or compressive? Okay, let's consider point A. This line is called C1, clockwise, C1. So going here, C1 is going down to the left, C1. So that means the force acting on this member is going down to the left, should be in that direction. That's C1. How about if we consider point B? That will be 1C, clockwise. Again, it's clockwise. It should be red clockwise, 1C. So 1C is going up to the right. So it's going up to the right, 1C. And how much is this? That's 0.78 kilonewtons. Remember AD, you consider point A, it is read as 1A, 1A. 1A is from the left upward to the right. So from here, it goes to the right. At point D, it is read as A1. A1 going down to the left. And how much is this? That's 4.1 kilonewtons. 4.1 kilonewtons. How about member BC? If we use point B, this is read as D2. Clockwise, it's D2. So D2 is this one, D2. So upward to the left. So it's compression. And at point C, it's 2D. 2D, it's going down to the right. And how much is it? Let's just measure this. 5.02 kilonewtons. That's 5.02 kilonewtons. And then remember CD, if considering point C, this is A2. A2. Where is it? Here we are. A2. So upward to the left. A2. Upward to the left. And then considering point D, that's 2A. 2A downward to the right. And how much is that? A2. This one. It's 4.1 kilonewtons. 4.1 kilonewtons. What else? Remember BD. This is very small. Let's just copy this. Put it in here. So considering point D, that's 1, 2. 1, 2 is going up. So it's tensile. And let's copy this. Point B. Put it over here. Point B, it's 2, 1. So it's going down. 2, 1. Anyway, this is. And this one is. So how much is BD? That's 1 to this one. So this is 4.1 kilonewtons. So here are the forces acting on each member. So AB is compressive at 0.78 kilonewtons. AD is 4.1 tensile. BD is 4.1 tensile. BC is 5.02 compressive. And DC is 4.1 tensile. Let's see if we get the correct answer. Go back here. The reactions are correct. How about this one? This is FCB or BC. It's 5.02 compression. BC. This one. Okay. So 5.02 compression. Correct. 5.02 compression. What else? We have FCD, 4.1 tension. CD is this one, 4.1 tension. 4.1 tension. What else? We have DA or AD, 4.1 tension. AD is this one. Okay? So 4.1 tension, 4.1 tension. What else? We have DB or BD, 4.1 tension. BD, this one. Okay? So 4.1 tension. What else? And AB is 0.776 kilonewtons compression. That's 0.78. 776, okay, 0.78 kilonewtons compression. Is it compression? Yeah, compression. So that's the third method, graphical method. This time we are using AutoCAD to solve the reaction as well as the forces in its members.